This is AP Calculus, section 4.2, page 6. Alright, so a seemingly unrelated topic, we're going to do some anti-differentiation. And if you think about differentiation as kind of going forward, anti-differentiation is going backwards from f prime to f of x. Okay. Alright, so let's just start here, and we are going to start going on forward here. So if f of x is 2x cubed plus 4x squared plus 9x plus 1, then f prime is 6x squared plus 8x plus 9. And looking at this one over here, if we do this derivative, f prime is 6x squared plus 8x plus 9 again. These two functions, the only difference between the original functions was this constant at the end. So we can say from this that two functions that differ only by a constant have exactly the same derivative. Two functions that differ by a constant have the same derivative. Or I should say differ only by a constant have the same derivative. So we can use that idea when we want to try and start going backwards here. So if f prime of x is 6x squared plus 8x plus 9, can you go backwards and find f of x? So what thing when you take the derivative of it gives you 6x squared? That's 2x cubed plus, and what thing when you take the derivative gives you 8x? 4x squared plus a 9x. Now, how do we know whether that's a plus 1 like up here, or a plus 17, or a minus 23? We don't, so what we'll do is put on a plus c here, where that c stands for some constant. So when we look at this one, if f prime of x is 3x squared plus 4, then to find f of x, we'll do an antiderivative, so we'll think backwards. What thing when you take the derivative of it gives you 3x squared? It would have to be x cubed plus, and what thing when you take the derivative of it gives you a 4? Yes, a 4x, and then plus that constant to handle some number that could be down there. Alright, taking a look at this next one. What if f prime of x is 10x cubed plus 7x squared minus 9x plus 2, and we want to find f of x? Well, clearly we know that to get this 10x cubed, we must have had x to the 4th before. So if we think about it, what would we have to put in front right here so that when we bring the 4 down, we get just 10? About 10 over 4. And then for this 7x squared, the derivative, in order to get that 7x squared, we must have had an x cubed. So what would have to be down here so that when we bring the 3 down, we get a 7? How about 7/3? Likewise, with this 9x, that must have come from a x squared. When we pull that 2 down, this must have been a 9 over 2, because 2 times 9 over 2 is 9. And then plus a 2x, and don't forget the constant, plus c. And we can go ahead and simplify here. F of x is 5 halves x to the 4th plus 7/3 x cubed minus 9 halves x squared plus a 2x plus a c. All right, now what if f prime is 1 over x minus 1? Well, what kind of thing, when you take the derivative of it, would give you a 1 over situation? Yes, that's a natural log. Natural log of x minus 1 plus a c. And this piece right here, this x greater than 1 for the domain of the derivative, that just guarantees when you get that natural log in here, you are taking the natural log of a positive number. Look down here at this one. If f prime of x is sine x, find f of x. So what thing, when you take the derivative of it, gives you sine x? Negative cosine x, exactly. Don't forget that plus c. And this last one over here for this page, what thing, when you take the derivative of it, gives you a sine 2x? Well, that's a cosine 2x, because the derivative of cosine is sine. However, if you did the derivative of this cosine 2x, it would be sine 2x times 2. So we need to put a 1/2 out here so that when we do the derivative of this cosine 2x and then times the 2 on the inside, it cancels out with that 1/2. Okay. More antiderivatives on the next page.